It sounds too crazy to be true, but a new hypothesis now explains how the Big Bang could never have happened. With the James Webb Space Telescope, we are entering a whole new era of astronomical discoveries, and this new scientific era will completely change our view of the universe. Mankind has experienced many revolutions in the way we see the world, and now we are all witnessing another great upheaval. These are exciting times, and we should look forward to seeing what new explanation scientists come up with for the universe when it is finally established that the Big Bang never happened. James Webb is a space telescope that was specially designed to show us the beginnings of the cosmos. Its range of about 13.5 billion years takes us to the epoch shortly after the end of the Great Darkness in the universe. At this time, the first stars are said to have appeared. Light filled the previously dark space, and then at some point, the first stars came together to form groups, which billions of years later became the enormous galaxies we can still see today. However, recent observations by James Webb have revealed a remarkable number of galaxies with surprising details. The observational results have shaken the scientific community, and they show us in an impressive way that the beginning of the universe was quite different. The universe, as an immeasurable sea of stars, galaxies, and unfathomable phenomena, still remains largely a mystery that we could never quite decipher. Despite the many scientific explanations, we have been certain for around 100 years that we knew how the universe began with a Big Bang, an event that gave birth to everything we can see today from a single dense and unimaginably hot point. But this idea is slowly crumbling. Every advance in astronomy and cosmology takes us a little further in our understanding of this infinite space, and now we are on the brink of a veritable revolution. For a long time, the latest observations made by Hubble and many of the world's best telescopes seemed to support the old theory, but now everything is different. The idea that the Big Bang occurred 13.8 billion years ago is now being questioned. Have you ever wondered how scientists came up with the age of the universe, even though they have never seen the universe in its entirety? It was something like this. Two researchers named Georges Lemaitre and Edwin Hubble observed galaxies moving away from each other around 100 years ago. It was then that the redshift was first noticed, which scientists still use today to determine the distance and age of galaxies. The behavior of the galaxies led Lemaitre to conclude that the universe must have once begun at a single point. Since then, astronomers and cosmologists have spent decades collecting more and more data by meticulously observing the movement of galaxies and using these patterns to back-calculate. They took all known physical quantities and laws and then calculated an age of 13.6 billion years. It was only a few years ago that this figure was corrected to 13.8 billion years. The reason for this adjustment was that technology had improved considerably in the meantime. One of the main sources of information for astronomers is the cosmic microwave background radiation, which is considered to be a remnant of the Big Bang and, like the movements of galaxies, shows signs of an expansion of the universe. However, there were also doubts about the calculations, as the universe does not show the same linear expansion behavior everywhere. These observations led researchers to other exciting ideas. Lemaitre and Hubble's idea was comparable to a whirlpool fed from a single source. The swirling motion of the water initially suggested that there was only one source. However, researchers have since found movements in the cosmos that look like a whirlpool in which the drive of the water and the spirals suggest several drives. At this point, completely new theories of the pocket universe, the universe within the universe, and the bubble universe emerged. The latest observations from the James Webb Space Telescope are now giving new impetus to such theories. Whether we will soon have certainty about the multiverse is truly written in the stars, but what is certain to come is the complete reassessment of the age of the universe. James Webb surprised everyone. Who would have thought that this telescope would turn the world of science completely upside down? James Webb was actually sent into space to finally confirm theories such as the Big Bang, the dark era of the universe, and the cosmic dawn. But the images from the new telescope show an unexpectedly large number of galaxies that are characterized by their smooth nature and great age. These discoveries are in complete contradiction to what many astronomers and cosmologists have predicted based on the Big Bang theory. The traditional idea that the universe emerged from an initial highly dense and hot state and has been steadily expanding ever since is called into question by these new observations. In particular, the existence of galaxies that are ancient and surprisingly structured does not fit the picture of a young, chaotic universe. The oldest galaxies discovered by Webb are Glass Z13 and Maisie's galaxy, both of which have a redshift of approximately 13Z and are therefore far older than 13.5 billion years. At the time they emitted this light, they could have been just 200 to 300 million years old, according to the Big Bang theory. If we subtract another 100 million years, which would roughly correspond to the Dark Epoch, we would arrive at an age of 100 to 200 million years. The catch is that the same laws that led to the calculation of the Big Bang and the age of the universe mean that exactly this is not possible. Galaxies of this smoothness and structure take billions of years to evolve. This would mean that these two galaxies would be older than the universe itself, and that cannot be the case. These discrepancies between observation and theory have now led to a wave of discussion and speculation in the astronomical community. In this context, let's take another look at the merger theory, which is a central component of modern cosmology. It states that galaxies grow and evolve through the process of colliding and merging with other galaxies. This theory explains how small primitive galaxies evolved into the complex structures we observe in the universe today. If the age of the universe is roughly correct and galaxies such as Glass Z13 or Maisie's galaxy have simply grown faster than previously assumed, there must be something wrong with the merger theory. In very simplified terms, the model assumes that smaller star clusters have merged with other star clusters, forming the first small bulky galaxies. Later, through further mergers with other galaxies, these became such magnificent phenomena as our Milky Way or the Andromeda Galaxy. However, the data from the Webb telescope show a different picture. Galaxies that already have a complex structure at an early stage of their existence. If galaxies already exhibit complex structures at an early stage of their development, then scientists must also completely reassess the role of collisions and mergers in galaxy development. Until now, for example, researchers have assumed that magnificent shapes such as the spiral or even the wagon wheel-like galaxies could have played a more important role in the early evolution of galaxies than previously assumed. Expansion and the Big Bang do not go together. Here's an interesting fact you may never have heard of. Scientists were, after all, ultimately using the idea of expansion and extrapolating events back to the Big Bang based on these observations. But the discoveries of the Webb telescope also shed a completely new light on the theory of cosmic expansion. The existence of old, structured galaxies in a state that is not consistent with a continuous expansion could be proof that the universe is not expanding and that the movements that we have interpreted as expansion have a completely different cause. In fact, the existence of these old structured galaxies even allows us to conclude that the universe was in a stable state 13.5 or 13.8 billion years ago. This would also mean that the Big Bang and the expansion driven by it may never have happened. At present, there is much more evidence that all these theories are wrong or at least have significant weaknesses. Researchers are still trying to somehow adapt the new findings to the old standard model. The traditional view of the Big Bang describes it as the moment when the universe emerged from an extremely hot and dense state and began to expand. However, the new telescope observations suggest that the Big Bang was not the absolute beginning of the universe. An alternative theory that is officially being considered is Sir Roger Penrose's cyclical universe model. The British researcher describes the Big Bang merely as a transitional stage from one universe to another. This would mean that the universe is only one of many in a much larger cosmic cycle, and the theory leaves room for certain structures of the old universe to appear in the new one. But even according to Penrose's idea, there was a starting point from which new stars and galaxies should have formed. However, we currently see absolutely nothing of these. The researchers only found galaxies that all appear to be very old. This actually speaks for a universe that is much older than previously assumed and possibly also for a universe that is infinite in both time and space. Scientists know this model as the steady-state universe, which is an eternal, unchanging universe without beginning or end. Although this idea stands in stark contrast to the idea of a dynamic, evolving universe, it could provide a possible explanation for the existence of the old structured galaxies. Will we ever know the truth? The magical thing about all these discoveries is the threshold they now bring us to. The old theories can no longer be upheld, and we will surely soon have a completely new cosmological worldview. It's not yet certain what this new picture and knowledge will look like, nor do we know when it will be ready. Ultimately, we need more evidence and more images from the early era of the universe. It is also possible that researchers will find a common thread using the data already available, and we'll be able to combine other theories and current observations to create a new coherent picture of the world. This may even bring us closer to Albert Einstein's lifelong dream. The greatest astrophysicist of all time dreamed of summarizing all the phenomena of the cosmos and all the forces at work in it in a unified field formula. He never succeeded. His own discovery of all things foiled his plans. What many people do not know is that Einstein was not awarded the Nobel Prize for the discovery of the equations of relativity, but for the first discovery and description of a particle of light that we now know as a quantum. Einstein ushered in the era of quantum physics, which was not at all compatible with the theories from the world of great phenomena. Perhaps the discoveries of the James Webb Telescope are now pushing us more and more in the direction we need to go to finally bring together the physics of the smallest particle and the physics of large-scale phenomena. As we delve deeper into the cosmos with advanced technology, the James Webb Space Telescope's findings are setting the stage for groundbreaking shifts in our understanding of the universe. The telescope's observations challenge previously held notions about the formation and evolution of galaxies. For instance, the discovery of highly structured galaxies from an early epoch suggests that our current models of cosmic evolution may be incomplete. The complexity of these early galaxies implies that they formed under conditions that differ significantly from the models predicated on the Big Bang theory. This revelation prompts a reevaluation of how quickly galaxies can develop intricate structures. Current theories may need to be revised to account for the possibility that galaxies can evolve more rapidly than previously thought, or that different mechanisms were at play in the early universe. Another intriguing aspect of these findings involves the distribution of galaxy types and their formation rates. The James Webb Space Telescope has detected a variety of galaxy morphologies that were not anticipated in the early universe. This includes both large, well-formed galaxies and smaller, more chaotic structures, suggesting a more complex and diverse early cosmic environment. The presence of such diversity challenges the idea of a uniform, predictable evolutionary path for galaxies and hints at a more dynamic early universe. The data from James Webb also brings into question the assumed timeline of cosmic events. The traditional model suggests a gradual formation of cosmic structures following the Big Bang, but the observations reveal that significant galaxy formation may have occurred much earlier than previously estimated. This discrepancy raises questions about the processes that governed galaxy formation and growth in the universe's infancy. Moreover, the telescope's insights into the chemical composition of ancient galaxies are reshaping our understanding of cosmic chemistry. The discovery of galaxies with advanced chemical enrichment at such an early stage suggests that the processes of star formation and supernova explosions occurred more rapidly than previously believed. This rapid chemical evolution implies a different pace of stellar life cycles and supernovae, which could affect our understanding of how the building blocks of life spread across the universe. In addition, the presence of highly structured galaxies from the early universe poses challenges to the current understanding of cosmic inflation. The theory of inflation posits that the universe underwent a rapid expansion immediately after the Big Bang, smoothing out any irregularities. However, the observed structures in early galaxies suggest that this process may not have been as straightforward as once thought. If the universe was more irregular and complex in its early stages, the mechanisms behind inflation and subsequent cosmic evolution may need to be re-examined. The implications of these findings extend beyond astronomy and cosmology, touching on fundamental questions about the nature of space and time. If the universe's early conditions were vastly different from current models, it could imply a need to revise the fundamental principles of physics. Researchers may need to integrate new data with existing theories to form a more comprehensive understanding of the universe's origins and evolution. As scientists work to incorporate these new findings into existing frameworks, they face the challenge of reconciling the observed data with theoretical models. This process may lead to the development of new theories or the refinement of existing ones to better fit the evolving picture of the cosmos. The James Webb Space Telescope's observations are pushing the boundaries of our knowledge and encouraging a rethinking of long-held assumptions about the universe. Ultimately, these discoveries highlight the dynamic nature of scientific inquiry. The ongoing refinement of theories in response to new data is a testament to the scientific method's strength. As researchers continue to analyze the data and develop new models, we can expect further revelations that will enhance our understanding of the universe and our place within it. The journey from the Big Bang to the present day is far from over, and each new discovery brings us closer to unraveling the ultimate mysteries of the cosmos.